Okay. Here we're going to start structuring the model. And if we careful with this, instead of putting any kind of financial or even economic or monetary assumptions, let's start out with the characteristics. I'll call this a plant. So part of this idea is really to uh, uh, illustrate the structuring idea of a model, to keep it very clean and try to, at least. I don't know if you'll agree that I do this. And uh, uh, you know, uh, uh, begin with the fundamentals. So let's put the plant capacity. Okay, and let's put this in megawatts. Now the second thing to do will be to transfer some of these variables. So let's say we have I don't know, a 50 megawatt plant. Okay, and then the next thing we need to think about is the why don't we think about the degradation? Now that's kind of changed a lot these days, but I think let's put the period here. So this is going to be now. If you've watched some of the other videos, this is kind of basic, but let's start with the commercial operation date. So let's keep all of the periods, and then we'll say, okay, in the first year it's this, and then we can put E date and go over to this and put 12. So in the next, of course, shift control 3, in the next 12 months we'll make it go lower. So maybe I think we might have what is it about? Let's say this is 0.4% per year. Uh, uh, okay, and then let's, this is going to be a little bit higher. I don't know if I should do it. I'll put 1.2%. It might be 1.5%. I should double check that. You'll help me. Now we have to adjust this to monthly, and finally let's do the let's think about the yield. Okay, and let's talk about these previous ones we've done. Okay, and how about we'll put the gross yield. Now, why don't we? I'm gonna stop this for a minute because I'm gonna get some data into here for the month by month yield, and we'll try to put some standard deviations in here, and we'll we won't do it like the consultants do it quite, but maybe look a little different. Okay, so hang on while I get the data. Okay, I'm a little nervous about this, but what I did was got from our earlier analyses the different um, places, I mean different estimates. We have, here's the average, and I just took the standard deviation of that. So the standard deviation relative to the average is 4.15%, which, by the way, was a lot bigger than the variation from year to year. And then all I did was copy the one from the EU website, which really seems to be the kind of good source for this stuff. Now, the once we have this, let's make an adjustment. Adjustment. Come on. Let's just say that, okay, we're going to start with this. This is our base kind of number here, where we had the month by month numbers. Let's take this one. Oops. Let's take the average. Okay, because what we're going to do is then incorporate uncertainty related to the fact, and this might be the most important kind of uncertainty. Um, okay, Shift Control P. So that's our adjustment factor, and then we can get our daily. Then we can get our daily and our daily with tilt. Okay, so what we'll do here is just multiply this one by an adjustment, Shift Control 1, Control D, and then let's take this one and multiply by the tilt. Now, I don't understand that tilt thing really. Why? Somebody will have an answer for me. I should have understood it a little more, but there's a reduction in a couple of months in the tilt. Now, Shift Control C, so we can clearly see the what are calculations. Now, this is watt hours per meter squared per day. If I suppose, why don't we just do it like this, and then get these last two. Okay, oops. I guess we should put days. Okay, can you just wait while I do this? Okay, I put the days in. You know, just remember this, that Halloween has 31. That's kind of how I'm sure you can remember it better than me. And then we can take a weighting of this. So let's take this weighted multiplied by this one. Okay, and then how about, and then we divide that by the total. Okay. Did I do something wrong? L 36 times. Hang on. Oh, okay. And then we can sum this. Alternate equal. That worked this time. Okay, so that's our weighted sum. Weighted with. This is horrible. Okay, I don't know how I'll ever understand this even tomorrow. Okay, so then we have the kind of this is the amount we'll have, but we'll make certain adjustments to all of this. Now, if we want the hourly, this is the average daily. You know, this hourly is kW. Oops. No, yes, this is watt per meter squared. So I hope that they're generally 24 hours a day. It's true there's an exception for some places. Okay, so Control R, we don't really need these ones. Okay, and then we can get the kind of gross capacity factor, which is simply this one divided by our 1000. Which is the, you know, the thing at the standard temperature conditions. Okay, so Shift Control P. So that's kind of our starting point, 21 or 23%. Really, it's the 21 that might be a benchmark. And then we can just multiply this by 8,760, and that's what we call the kind of production at full load hours. Some people call this the yield. I don't know why really. But it's how much you would produce as a percentage, how many load hours you would produce really. I don't even know if that's right because of the potential to produce a little more than 8,760, but I mean 1,000. So I pressed Shift Control C and got the all the answers. Now this is we'll kind of start with something like this, and then we put the losses in. And remember, for this we can put 1 minus these to kind of just keep going gradually down and compound on itself. So if we put equal product here, product, that's our total losses, and we can put 1 minus that, and that's really our Shift Control P. So our performance ratio is something like this. Okay, I hope. All right, and now let's do the next one. Once we've got this kind of built, let's incorporate the uncertainty. Okay. And so I think what we should do is for each factor, let's start with yield, gross yield, without tilt, and let's put adjustments, alternative measurement. And now this is supposed to be this idea that we alternative source. How about we'll call that alternative source. And then we'll okay, put the tilt in, and I'm gonna just put some arbitrary kind of uncertainties around some of these things, but please remember the idea of this is you should understand how the consultants did this. And I don't want to sound arrogant at all. I'm not, please, because mine are just out of the air, but I just wonder how much better the consultants really are. So after we have the tilt, then we can put on all of these things in. Okay? And, then finally we'll get the net yield. Okay, and when we get after we get the net yield, then I know it's not so necessary, but let's finally put this into the months. Okay, and so we put net yield per month. It doesn't really matter that so much that you have different ones. I suppose if you're sculpting the debt, you could have a different things. So and what we'll do over here is start with our P50 case, and then we can put our P75, P90, P95, and P99 cases, and then we can perhaps we'll put it over here, and this one we'll just introduce to you because I think we need a code number. Okay, so this time we'll use the index function, and perhaps we'll put our final one over here, so you can see where we're really going with all of this. Okay, so let's try to do this. I might have to interrupt a couple of times. So let's start with our base, our base percent. Okay, that's going to be our losses and everything else, and then we'll put our energy. Okay, and after we put the energy, let's put the standard deviation percent. Okay, and after we have the energy standard deviation percentage, let's then get standard deviation, and then we put squared, and that will give us our root square error. So we need down here net yield. Perhaps I'll put a separate one for root square error just so you remember this. Okay, and then we can get our this total root square error will give us our standard deviation. We can take this standard deviation and then take our net yield here, which is going to be this one. Maybe I'll put a little box here so we remember that's what we're aiming for. We take this one, which is our net yield, and then we better put the how about here, we'll put the percentage. Okay, and I gotta move that over here again. And do we have, I'm just gonna take our weighting percentage here. Okay, so we're just gonna, this is the you know, once we have the total here, we can or the average really. Okay, this better be the average rather than the total. Then we can take this average and push it up for some months and push it down for some months and get our P50s, P75s, and everything else. So let's see if we can do this. Okay, so for the gross yield without the tilt, let's get our base percentage here, and that's this one. Okay, I think. Okay, and then we can get, now we'll just leave this the same because this is going to, we're going to put an uncertainty around this. And then the tilt, let's just say, well, let's take this tilt minus the one without the tilt. Okay, and then the temperature shading loss, this time we'll start putting these as a negative, and I think we can just copy this down. Okay, and then we can put the now the energy is the way we did this, the way I did this energy is I just said, okay, this is the energy for a single hour, really. No, this is the energy, excuse me. That's the yield. This is the average hourly energy. So why don't we take the this one simply times 1,000. Okay. I don't know how necessary that is. No, we should take that, and then we should multiply this by our capacity. So this is our, we've got to be a little bit careful. I'm going to have to, so we've got 50 megawatts. I'm sorry, it's just, if we want the energy, it's just the capacity factor times the 50 megawatts of capacity. Okay, F4 times, of course, 8766 with the leap year. Okay, that's, and these are okay, and why don't we put this as a percent, even though I set it to percent, and then this is megawatt hours because we started with 50 megawatts. Okay, and okay, so this is just the pieces of the different energy. I hope we have this okay. Now the standard deviation percent, well, that's, you know, the what we had is, if we looked at, oops, this is something, if we looked at this one, we did all this kind of analysis, and we found out, okay, there's only about a 2%, 2.08, so we can kind of remember that. That was the P90 really stuff, so we can put 2.08% here. Okay, and then alternative source, well, I thought that's a lot bigger. That's be the big one, 4.15%. And there's a major difference between these two. This is mean reverting. It just goes up and down. This one, if you made an error, it's an error forever and ever and ever. That's kind of the thing here. And then the tilt, well, let's say there's a 5%. We don't, that tilt stuff, I don't know. And then let's say the temperature loss, we really don't know what that is. So that's 10%. Of course, these are taken out of the air. And let's put 3%, 2%, 4%, 1.5%, 3%, and 3%. I've seen people use about 3% for this stuff. Okay. And then, so then we can take our standard deviation as this multiplied by the energy. So this is the standard deviation in units. So we can copy these things over to here. And then, you know, this is the megawatt hour squared. I don't know what really. So we just take this one and square it to get our root sum error, you know. Okay, I guess it did work. Okay, and then if I'm doing this correctly, what we do is we sum this one, and after we sum it, we raise it to the 0.5 power. Okay, and that's our total standard deviation, and our net yield is the sum of these things. Of course, don't add the first one twice. So our kind of total standard deviation is this divided by this. Ooh, that seems really high. 3 and 4. Just a minute. I'm gonna pause it for a minute and double check this. Okay. Okay, it's not that unreasonable. When I take out all of the losses and everything else, we have a much higher net yield. Let me see if I did something wrong with the losses. So we put these losses back here. Whoops, and we make it a minus. Okay. And, well, perhaps I overstated the losses because these losses were... of course, these losses I did incorrectly. Excuse me. So I did make a mistake. Good, you get to watch all my silly mistakes. Okay. Loss factor or something. So let's just take this one plus 1. Okay, that's our... and then we... so our losses are this one times the how about we should really compute the subtotal. Let's I wonder what that's going to do. I think it will be okay. Sorry about this. We could add these together. Okay, I was going to use the alternate equal, but I won't. Okay, and I'm not. We won't do it over here or over here. Okay, and whoops. Okay, let's. Okay, excuse me. Okay, added a little one. Okay, and then we can. So this, our losses here are this times this, but then we in the next one we better take the we have to take the subtotal. So this one okay, so it's this one plus this one times this, and then I really didn't need that last thing. This one plus sum of these. Okay, excuse me for this, times this, and then the sum of these times this, sum of these times this. I don't even know if that's actually, if we compound the losses like this, but I assume we should. Okay, and there we have it. Okay, so now we have a, now the net yield is going to be the sum of all of this. Okay, which, okay. And we can put that in terms of a capacity factor as well, I guess. Let's compute the capacity factor. So remember, that's this one. This is the energy. We better divide by 8,760 to get it per day, and then divide it by 50. And that's our capacity factor. So we put it up by the tilt. Just a minute. Why it looks like I've still got something wrong. Hang on. That's okay. This 3.16% is not like a loss factor. This is like a capacity factor. So I'm okay. Okay. And then let's put some stuff back here. I'll put 10%, 2%. Oops. Ugh. 2%. How about 1%, 4%, 3%, 5%, 4%. So those are our losses. Then now we can compute this thing, and I guess that's okay. That once we have the standard deviation, we just square it anyway, so it doesn't matter if it's stated as a positive or negative. And now we have a total standard deviation percent of 4.64%. That makes a whole lot more sense. So the root square error, well, this is the root square error. So let's move these down. Okay, and now we can finish this up, hopefully. So let's take the energy generation, which is that one, and the average for the month would be divided by 12, and we multiply that by the percentage and press the F4 a few times, and that's our P50 case. Okay, now we could, I suppose we could, I'm going to go ahead and just do the P75s and all that here. So what you can do is put 25%, 10%, 5%, and 1%. And then we can put the norm inverse. Okay, and to get the norm inverse, we start with the probability, press the F4 a couple of times to get the row correct, and then the mean is, we'll just use this mean all the time, so put this over here, just the F4 here, and then the standard deviation, let's take this one, times the mean. Okay, and we can put this all the way down. Okay, so then we have our different cases, which range from this yield to that yield, and we have it by month, and then we can just use our code number to, and this is really, maybe I'll put it over here. How about this? Index I'm not going to repeat the index for the umpteenth time, but you put an array in and then often use this code number. Okay, and okay, shift down, control D, shift control 1, and this is really what's going on going into the model, so perhaps we'll put a little box around it. Okay, and you know, maybe here I think we need to put the month number. It would have been nicer to make the month go across so we can use the lookup, but let's see, we'll come up with something. No, I was gonna, shoot. Alt-DIS, enter. Okay, and those are our assumptions. Now let's do one more thing, a couple more things. Let's press the Shift Control C, and we can see really what the inputs we had versus the assumptions. Okay, and now let's go to the operations, and of course we had EBITDA here before, but let's start with the so this is going to be our plant characteristics. Now you remember what we did was we had a project finance page. We don't really need this one anymore, this page for right now, because what we only need to transfer is things like the EBITDA and everything else. So I'm going to put this, call this solar plant characteristics. Okay, and so let's do the first one easily. Let's put the plant capacity. Now, I think we should put, let's put the units here first. And now let's get this from the other page, the first page. Now, one of the things that has been for me, this was such a pain to do, so I have to show you. So if we make this a tab color red, I've done this before. Now this is only because the generic macros are open. If you go to the add-ins and go to this has got no. Oh no! Hang on. Where's our generic macros? I'm gonna have to close this file, and then let's open the file called generic macros. Oh, it says it's already open. Now, you know what I better do is, if you go to, because I have another one open. This is not usual for me. Let's do this one, and you see this one that says implement the generic macros. Why don't you run this one? And then now our add-ins should be okay, and we just put color cells from tab color. We'll do this later. Okay, ooh, this red was not a good idea, because we have red for the, how about we'll make the tab color some other red. Okay, how about we'll, ooh, it'll look a little funny, but why don't we make it purple? Okay, so this time if we go to color sheets from tab color, then we can differentiate the falses from that color. Might not be very good, but what the heck, I don't care. Okay, so now we can take our plant capacity and multiply it by the operating light switch. Shift Control 1, Shift Control R. Okay, and then we have our special little thing, and of course I made a ridiculous error by not using the F4 key on this one. Okay. Okay, so we now we have the plant capacity. Now let's put the degradation. I'll put the annual degradation percent, and let's put it as a percent. Now this time we can't read it directly in, so we have to use the lookup. And the nice thing about the lookup here is first always use the start of the month if it's going to be a start of the month kind of thing, and then we can click if you make it sideways like this. You know what I mean by sideways? You put the date on the top and then this, instead of making it go down in different rows, then Shift Control. Whoops. Now, this is something I hate. So here's what I'm going to do for once. I'm going to go to the generic macros, and in the developer on the generic macros, if you go to macros, okay, and then you go to, I hope I have functions here. Where does it say some, just a minute, list, not the list functions. Well, maybe, let's see. Is this, we have some functions here. And I have this function called lookup NA. So I'm gonna, all this does is, I hope, I'm afraid it won't work, but I'm copying this. If it doesn't work, I'm gonna do what I always do. I'll stop the recording. So let's go to this sheet. This is, okay, and we have one macro so far, because we put some functions in. Yeah, we put, remember, last time we put the end of date. So this is the lookup function. And this one that we call test, why don't we call this functions? Functions. I think this won't mess everything up. Okay, and then let's change this from lookup to lookup underscore NA. Okay, I hope that didn't slow things down. Shift Control R. It might have. Okay, and then we can press Shift Control P. So that's our, then we get rid of this horrible NA stuff. I hope that didn't. I'm afraid that one might. These functions can maybe slow it down a little. And then let's put periodic degradation, because we have this, and I think what we need to do is somewhere here put, how about we'll put it down here. No, I'm going back and forth, excuse me for this. I'm gonna put months to make year, periods to make year. So in this case we have 12 periods to make a year. This is just, I can't do that. How about we'll put periods to make year in the operations, but let's just put periods. 12. Okay, of course. Shift Control C, and we put this here. Okay, Shift Control 1. F4, oops, not F5, F4. I'm a little bit, okay, I'm a tiny little bit worried that it's calculating here, but how about, okay, we can do it like these fancy people. Why don't we just, for a minute, put it to manual, and then we'll Shift Control R. And then the periodic degradation will be 1 plus the annual degradation raised to the 1 divided by the 12 minus 1. Okay, shift control P, shift control, whoops, what happened? Shift control R, and then we can put degradation index. Degradation index. Okay, so this is just percent, and this is an index. Okay, and then we'll start with just the number 1, and then we'll take this 1 and multiply by 1 plus the degradation index. Okay. Okay, and then we better calculate the sheet. This is horrible. Okay. Okay, and I did something wrong because 1 plus. Okay, just let me stop here for 1 second. Okay, there was no problem actually. It was just taking a bit to calculate. And now let's put the I think we can put the generation in here, and I think we can use the lookup, because what we should do here is under here, let's put a couple of other things. Let's put the year and then the month. Oh, God. Okay. Okay. Maybe that stupid thing wasn't worth it, but okay. The year is just equal year. Of course, it doesn't matter whether you take this one, the first one, or the second one. Shift control the tilde or the approximate sign to the right of the 1, and then the month is the next one, which is just this one. Again, it doesn't matter which one you take. Shift control R, and now let's put the okay, let's put the let's put these things in. Then we put we're going to look up on the month and put this thing in depending on the lookup, and we'll only do it when it's the operating period. So why don't we do it without that? Well, okay, so we can do it here, and then we can put generation before degradation. Okay, better make it a little wider, and we'll put that in megawatt hours, and we put again lookup. This time I don't think I need our lookup NA, which might not have been quite as good as I thought it was. And then we look up the month. Okay, and depending on that month, we first look up this one. Now you have this one, we only have to press the F4 key, so that I didn't, I can't find F4, and then then let's put in this one and press the F4 key again. So obviously I'm having a problem with F4 keys today. Shift control 1, and then let's put a little if statement before there, or better yet, let's just multiply this one by the operating switch. Okay, shift control R, And then let's put the degradation generation after degradation. And that's in megawatt hours as well. And that's just this one multiplied by our index. And I did a crime. Oh, God. Okay, Shift Control R. I didn't. Shift Control R. And let's calculate the sheet. You can, of course, press Shift F9. Now that one seemed to go a little more quickly. Why did that one go more quickly? I have no idea. So this is our net generation, and it switches off. And I hope you can see that it's important to start this whole analysis with what the project really does. I know you can get really fancy with all of our project financing and our structuring and all of this stuff, but we really need to first and foremost understand how much electricity we're going to actually produce, and it also happens to be that that's the largest risk we have. Okay, and so now I'll save the file, and I hope this is called Solar Plant Characteristics. It's in the wrong place, but put it in the, how about I'll put it in I'll put it in the renewable template financial models. Okay, not a perfect place to put it. And I'm going to stop this video, and then the next one we'll talk about the capital expenditures for the solar. Okay.